Okay, so I think this follows on really, really nicely actually from that last one, because what Shiga was just talking about there about what Industry 5 is and the sort of the prospects and how do we measure it. We wanted with this project to kind of go back and think about, okay, what are the prospects for that transformation and how do we understand what Industry 5 is in the first place? And so I want to start us there. And I suppose we've just got a little image here, which is what I think a lot of us had in mind when we started the project to think about what Industry 5 looks like. It's the kind of thing that our students would come up with as well when we're teaching, when we ask them about what the future of work is like and what it's like to manage. And I think this is kind of, for me, almost encapsulates the idea of a fully digitalized bit. So if you think about Industry 5 as a twin transformation, digitalization and sustainability, when we think about the digitalization, it brings us to something like this. The idea that we can create a digital twin that will model perfectly everything that is happening in the organization and will give us a perfect, like-for-like representation or simulation of reality that enables some sort of control over that reality by tweaking with it and making it visible. What we found, and I guess our pitch with this project, was that perhaps the reality of human beings is a little bit more complicated, and we were interested in what eludes those sorts of digital metrics. So I'll pick up on a couple of those ideas, but just to start with, obviously, with a project on Industry 5.0, we wanted to understand what Industry 5.0 was. Everybody we asked gave us a slightly different definition of it. When we asked some of our colleagues and our partners who were working with us on the project, they would tell us things like, well, we're not even, I think, at Industry 2 yet, never mind Industry 5. So we went back and looked at some of those founding documents from the European Commission that were published, and there's a few of these policy briefs that kind of came out on what Industry 5 was. And I've just put this one up. It starts as, you're like my childish scrawl. I'm afraid I wanted to go very analog rather than digital here. It starts as a contrast with Industry 4. So it's defined almost in negative. Right? Industry 5 is necessary because Industry 4 failed, as presumably did 3, 2, and 1 on some kind of criteria. So it starts, although it has a positive value, and we'll come to those 3 pillars, in terms of a contrast with Industry 4.0, as currently conceived, is not fit for purpose. It is structurally aligned with business models and economic thinking that are the root causes of the threats we now face. The current digital economy is a winner-takes-all model that creates technological monopoly and giant wealth inequality. So this is from one of the policy briefs from 2022. If we take that forward, and there's 4 of these sort of founding texts that were the key ones when we started this project. There are now loads more and hundreds of articles, particularly in the MDPI journals, on what Industry 5 is. So it's even more contested, I would say. What we do have very clearly is that it's based around 3 pillars of resilience, sustainability, and human-centrism, which we'll pick up in a minute as well, as some people have. But some of the kinds of things that we picked out here were, it's very much future-orientated. There was a recognition that there's a generational change amongst the workforce, and that what Generation Z or Z want is perhaps not the same as what our increasingly aging workforce in the manufacturing sector in Europe is actually experiencing culturally, that there might be a kind of a generational shift. There's also a lot of discussion about the donut economics idea around sustainability of living within planetary boundaries, that we have a desire for green growth, and yet there are fundamental limits to growth. We've kind of known that since the 1970s. It's just a basic kind of fact, right, of reality. You can't infinitely grow on a finite planet. So how do we conceptualize an idea of economic growth in a model that's, let's call it capitalism, because these documents do, based on growth? So there are references to living in a post-capitalist world, or at least overcoming the worst excesses of neoliberal versions of capitalism. And thinking about how, and this is where the last 3 presentations have been really interesting in terms of the quantification. How do we come up with metrics that allow us to evaluate economic activity that aren't just reducing everything down to a single GDP figure, which we know is correlated really highly well with carbon emissions that are causing climate change and global warming? So you have things like this statement: the Industry 4 paradigm has to be rejected because it is essentially technological, centered around the emergence of cyber-physical objects and offering a promise of enhanced efficiency through digital connectivity and artificial intelligence. which doesn't really help us to deal with the fundamentally social bits of human organising. It's a technological vision. So the idea of Industry 5 was to move into a much more social paradigm, hence putting human centrism at the heart of it, things like resilience, paying attention to the social and the political dimensions of organising, not just the technological. However, what we found when we started to talk to people about what Industry 5 was we would usually get a litany of technologies. Oh, well, it's about cobots, not robots. Oh, well, it's about cyber-physical systems, which, hang on, that's about the same as Industry 4. So there was a blurring around this, but a replacement, partly, we would argue, because one of the challenges about Industry 5 as a concept is it's what the kind of discourse theorists might call an empty signifier. It's an idea that doesn't have a very strong, clear content. So people can read it and project into it whatever they like. Now that might be projections driven by their anxieties, for example, when workers are concerned about being made redundant, or when managers are concerned about having their lack of expertise over the production processes exposed. We've heard a lot of discussion over the last 2 days about anxiety, and I think that's one of the things that can potentially drive this, because it becomes a kind of a container for this idea of what we would like to see, a more egalitarian future, but also some of those sorts of anxieties that get projected into that. Critically also, there's an important bit of it that is literally empty. If you take the idea of Industry 5, or you take the idea of Industry 5.0, what work does the 5.0 do? What does the 0.0 do? It doesn't mean anything extra, and yet it communicates quite a lot. It was chosen quite consciously to indicate a significant upgrade on a system. It wasn't just Industry 4.1, it was Industry 5.0, it was a whole new operating system. And yet it also signalled a continuity with what went before. It was one more than 5. And already when you hear Industry 5, you can imagine, well, at some point we're going to have to hit 6, 7, 8, 9, X. So X, I guess that's when Elon Musk actually owns the whole thing, Industry X.0. But I think also that 0.0 does a lot of work because it helps foreground that digital technology. So the digitalization comes in there. The 0.0 is like Web 2.0. It's a digital then. So it brings us back down to the technologies. So I think what we ended up with is a kind of a social vision, Industry 5, being over-determined by technology when we started to talk to the partners, but also when we looked at the discourses. So it becomes Internet of Things and cyber-physical systems. It becomes digital twins. It becomes simulation and AI and cobots and human-machine interactions. And in case you're wondering about the NAF art, this is what Copilot generates when you ask it what a Generation Z digital native Industry 5.0 worker might look like. Right? So that's the kind of, it's science fiction and it's really driven by the technology, and that's manufacturing. Similarly, we've had this in one of Chris's talks earlier, I'm not going to labour it, but we get the same kind of analogy. Industry 5 is about human-robot collaboration, cognitive systems and customizations, right? All the sustainability, human-centric, the social, the strategic bit has gone missing. So, what are the implications of this? Well, we think there are several when we think about the broader prospects for Industry 5.0, and that's what we were asked to talk about today. When we think about sustainability, one thing that we're hardly dealing with are the environmental impacts of digital technologies. These are actually quite profound, particularly when we start to look at AI. It's incredibly energy intensive to run and to train new large language models. Every single search that you do using an AI LLM instead of Google is using about 10 times the amount of energy. The data processing centers that are running these use water to cool. It has to be high quality drinking water to avoid clogging the cooling systems. Most of those are actually located in, well, quite often global south places where water access for drinking is actually quite difficult. And we have colleagues who are doing research looking at that in places like Chile, in South America, but also in Africa, where a lot of these data processing plants are being put. And yet, when we tend to think about the digital, because we don't see it churning out diesel like our dirty old diesel cars, we don't always think about the actual environmental costs. If you look at the waste rate as well on the sort of digital chips that are going into training AIs, then we've got a lot of these. So there's a basic tension between the objectives as a social and environmental sustainable project of Industry 5 and its transformation into a shorthand for digitalisation. When we think about resilience, there's some really interesting tensions there that come around. And we've heard about China and we've heard about the United States, and that's not coincidental. Part of the Industry 5.0 agenda is finding an alternative European way forward that isn't low-cost labour, mass manufacturing a la China, but is also not digital monopoly, techno-driven, whatever we currently have with Elon Musk's turn to the extreme right and things like this that we're seeing in the United States. Instead, it's a desire to create a European vision for a kind of socially progressive, inclusive version of industrialization and development that's offering something different. And yet, by hooking back into technology, we're still dependent on the United States, digital technologies. We're still dependent on China because it owns large amounts of even African rare earth minerals. It has a lot of the processing, refining abilities to create those. And, well, Taiwan is a hot spot at the moment precisely because it's a major center for silicon chip manufacturing through the Taiwan Semiconductor Company. So actually, we're kind of caught at the moment in trying to think about a way that might be independent, but we're doing it through using technologies that already build us into non-resilient, interdependent supply chains. So there's a sort of a tension. And then human-centrism, the third. By thinking about technologies, we quite often find, like the digital twins map that we had earlier, that we end up rendering, and Kendra Bricken has done a fantastic paper on this, looking at sort of engineering discourses and how Industry 5 gets translated into specific technologies. We end up treating humans as objects. So we start to talk about things like cognitive load. Well, how do we measure that? We can have in-ear EEG buds. We can measure eye tracking. We effectively de-skill workers from understanding their own bodies, their own cognitive processes. We don't ask them how things are. We measure them concretely so that we can then use that data and feed it into an AI system and build one of those digital twins. So we really wanted to try to present this idea that instead we could have an idea of the human as an active social subject that would be co-constructing democratically, like that alternative European progressive future, the ideas of a future that we might have that would be Industry 5 in a different term perhaps and less technologically orientated. Okay, so that was the big picture bit. What have we learned on upskill from this? Well, one thing to recognize is that less than 50% of employment is in large companies. About 60% of manufacturing companies are SMEs. These are fairly conservative figures, depends on how you calculate it. It varies by countries. It would be over 80% in the UK. Almost 70% of value added comes from large companies, but that still leaves a large portion with SMEs. By far, the majority of actual companies in manufacturing are SMEs. Those organizations, as we've heard from some of the previous presentations, have significant challenges around finance, around the absorptive capacity, around the ability to understand what the new technologies are, but also management training. You will often have in a small, medium-sized enterprise, somebody like, say, 20 people. You know, the managing director is probably also doing most of the finance stuff. They're making key decisions about that. They're probably a de facto HR manager. They're doing all of these different kinds of jobs, trying to do skills, make decisions about which technologies to invest in, trying to weigh all of these kinds of things up. And that also creates questions around cybersecurity risks. Without naming names, we've walked into companies where there are, you know, interconnected computers and laptops out there with passwords post-it noted onto the screens, you know, in a passageway that anybody doing a sort of an Amazon delivery would be walking past. So we've got those kinds of questions around that as to whether those create potential supply chain vulnerabilities further up, because once one place has got a virus, that can be traveling up and down the supply chain. So we've got some really interesting questions there around the technical bits. We've also noticed, though, that in all of the cases that we looked at, those really advanced digital manufacturing technologies are still utterly dependent on human skills. And I'll give you one example from car company. They brought in some 3D printing. They would make various things with 3D printing. for, say, like, for example, the hands to grab from a robotic arm. Yep, you've got these little plastic bits to stop it damaging the things that it's picking up. They've realized a way that they could print these very straightforwardly, but they still needed somebody to program that machine to design it. But even more importantly, when it was churned out from the 3D printer, it still wasn't quite right. They'd still end up having to do some little tooling and engineering. Might not have been a huge amount, but just a little bit of finishing on a machine tool lathe to actually make that thing working effectively. And when we get into maintenance and repair, we're not even close. So I always love it when my research is already a meme before I've even managed to publish it. But this would be the kind of current pitch at the moment. If anybody is a qualified welder and they would like a job in Scotland, I have a colleague who is working through the Welding Institute at the moment, is paying about £120,000 a year salary for qualified welders. Because anything that is not just a standardized job, doing the same thing day in, day out, cannot just be done with basic spot welding automated robots. If you want to do something that's unconventional and involves an analysis, it's a highly skilled thing. However, we've got generations of kids who have been told that the future, all the welding is going to be done by robots and don't even think about training as welders anymore. So it's really hard to get people into doing these traditional kind of metalworking skills, even though they're still essential. We've talked about resistance at all sorts of levels. I would agree with everybody who has said resistance is really the wrong way to frame these kinds of things. That resistance is actually institutionalized. And it's not just workers. In fact, the opposite. We found that there are inflexible management systems. Large organizations, multinationals, you go in there, they're reporting on quarterly returns. They have to reduce everything to cost savings within the next 3 months. If they want to engage in a new company to procure something, they've got a huge complicated bureaucratic system to go through this. And crucially, the accounting systems that we use to account for profit and loss, put labor costs as a cost, and put new technology as an investment. One's positive, one is a cost to be minimized. For most large organizations, the easiest thing for them to manage on a quarterly basis is headcount and staff costs. So if you can use something to automate, it becomes a short-term operational decision rather than a strategic decision. And I'll race ahead a little bit and jump to this one, but I think that's really critical for management. We need managers to understand that Industry 5, if we really want this, is not just an operational cost-saving exercise that you report on your quarterly basis and you reduce your labour costs. If we want to move to augmentation rather than automation and replacement, it's a strategic proposition. That means you need managers who can actually understand what strategically these transformations might deliver. Now, that could be things like a more sustainable business proposition. You can sell new products if you've got a more sustainable framework. It might be flexibility. It might be resilience if you can manufacture something in-house on a water jet cutter that you would otherwise be importing from India. It might give you some benefits in terms of IP risk, but it might also give you benefits if yet another cargo ship runs aground and blocks up a critical international channel for transporting those goods over. So it could create all kinds of different advantages, but we're shifting well away from thinking about what is a cost-based analysis. But that means that managers are going to have to get out of the office and stop looking at those little digital twins on their screens and actually understand what workers are really doing on the shop floor, what the actual competitive advantage they're offering are, and the full range spectrum of the skills that they're offering. We're going to have to get managers to really understand the technologies and not just be dependent upon people selling them products at trade fairs or looking at YouTube clips to try to find out what the latest technologies are. We need good, honest brokers like the Welding Institute, like the Made Labs, like the MITC, to be able to facilitate that kind of knowledge transfer for those small organizations. And we need to kind of also have a realistic understanding of what the motivations of young people are today. And that includes a kind of radical approach to HRM skills. How do we actually make these jobs attractive? How do we communicate what the reality of the future is work and sell that to our young people? I'll pause it there.